Transformers are essential devices in our power grid that change the voltage of alternating current. They allow us to transmit electricity over long distances efficiently by stepping voltage up or down as needed. A basic transformer consists of two main parts, a laminated iron core and two separate coils of wire. The primary coil is connected to the input source, while the secondary coil provides the output to the load. Transformers only work with alternating current. When AC flows through the primary coil, it creates a magnetic field that constantly changes its strength and direction, following the frequency of the input voltage. The iron core serves as a pathway for the magnetic flux. It concentrates the magnetic field lines, ensuring that the magnetic energy generated by the primary coil is efficiently guided toward the secondary coil. According to Faraday's law, a changing magnetic field through a loop of wire induces an electromotive force, or voltage. Because the flux is constantly changing, it induces a steady AC voltage in the secondary coil. The relationship between the primary and secondary voltage is determined by the turns ratio. The ratio of the voltages is equal to the ratio of the number of turns in each coil. In a step-up transformer, the secondary coil has more turns than the primary. This increases the voltage at the output, which is used at power plants to prepare electricity for long-distance travel. A step-down transformer has fewer turns on the secondary coil. This reduces the voltage to safer levels, such as the 120 or 240 volts used in your home appliances. While a transformer can change voltage, it cannot create energy. In an ideal transformer, power in equals power out. This means if the voltage is stepped up, the current is simultaneously stepped down to maintain the balance. Real-world transformers aren't perfectly efficient. Energy is lost as heat due to resistance in the wires and circulating eddy currents in the core. This is why the iron core is made of thin laminated sheets to minimize these losses. To summarize, transformers use electromagnetic induction to transfer energy between circuits. By varying the number of wire turns, we can precisely control voltage levels for any electrical application. Understanding these principles helps us appreciate the complex engineering that keeps our modern world powered. This educational overview was generated by Vision Solve AI.